We can do the part B after lunch. But what do you do if you have 4 terms? You can either do grouping or you can throw them into the box. So before you leave for lunch, see if you can set up a box and try to factor this cubic function. So you're doing it the box the same way that we've been doing it, or grouping the same way that we've been doing it. But they've given you the 4 pieces. You put the 4 pieces in the box and see if you can get it to factor. Now you're factoring a cubic function. So take a stab at it and we'll go over it kind of when we come back. And I can try example 2. Oh, I wanted to finish example 1 and point something out to you. This is doing 4 terms, and I know that you've never factored a cubic function before, but it's using grouping on a higher level function. I need to put the x squared on this side of the box because I see the x squared over here. So x times x squared, and then that would make this a -3, right, to give you -3x squared, and a -16 to give you the -16x. When you double check this lower right corner, that should make sense. -16, -3 gives me 48. I want to show you something that's a little bit different than boxed on the other page. So because this is a cubic function, one of these parentheses might be able to go a step further. See how this is a quadratic? Can that go a step further? That's a difference of squares right there, right? So if it says factor completely, you need to take this binomial the one step further. So you really have x minus 3, and then you have x plus 4, x minus 4, because that is that difference of squares. So with cubic functions, you might end up with just 2 factors or 3 factors. So could you try example B the same way? See if you can put it into a box or group it and see if you can get your final factors, if it has to go a step further or if it doesn't have to go a step further. For my video that x squared plus 1 couldn't go any further. So this was my final answer. I'm skipping the cubes. Okay, so this is one last thing. These are quartic functions. See how it's x to the 4th? Okay, so this is called quadratic form. We're going to pretend in our head that these are quadratics. So this is another strategy. How do you know to use it? Well, you've got an x to the 4th right there. So it kind of should be like, ooh, if I have a 4th degree, just like up here, I had a 3rd degree function, I'm going to use grouping. Down here, I have a 4th degree function. I don't know how to do that, so I'm going to use, just pretend it's a quadratic. See how this goes x to the 4th, then x squared, then a constant. Same thing over here, x to the 4th, x squared constant. What you do is you pretend that this is a quadratic function. So you just make this x squared, like standard form, plus 4x plus 3. I know those are not equal, This is a strategy. All right, everyone knows how to factor this quadratic, right? It's a trinomial, and I can just write x times x to get x squared, because now I'm back to just x squared being 1. And I can do the diamond, right? What are the factors of 3 that add up to 4? So what goes in my diamond? 3 times 1, x plus 3, x plus 1. When I multiply these binomials, I get back this circled quadratic. How can I make these multiplied to a quartic function, this x to the 4th function? All I need to do is make this an x squared and make this an x squared. So once you've factored it, you change this back to x squared inside the function. So x squared times x squared is x to the 4th. And then see how you've got your 4x squared going on with your outer and your inner, and then you've got your positive 3 with your constant. So it's a way of taking a quadratic, but it's actually you're factoring a 4th degree polynomial. And this is definitely a pre-calculus factoring concept, right? I didn't have my Algebra 2 students do this with cubic or do this with quartic. So this is kind of like the level up, right? We are relearning factoring, but taking it to one next step. So 5x squared minus 9x plus 4. I want you to work through putting that into a box, doing your box and factoring it, and then at the end, whatever you get in your parentheses, you just make those x squared terms. So you're looking for basically 2 negative factors of 20. A negative times a negative. Yeah, what did you say it was? Negative 5 times negative 4 gives you positive 20, but adds up to negative 9. So it doesn't matter which box, but I'm going to call that negative 5x, and I'm going to call that negative 4x, and I'm going to solve my box on the outside. Keep writing here. Let's see. X times x. Right, I know the 5x has got to go alongside the 5x row because I have to get negative 5x over here. So I'd have to multiply by negative 1 on top to make it negative 5x right there. And I'd have to multiply by negative 4 to make it negative 4x. So now I'm going to write my binomial x minus 1, 5x minus 4. But that only gives me back my 5x squared. So I need my power to be 5x to the 4th. So I make both of the x terms x squared and 5x squared to give me 5x to the 4th. Can either of those go a step further with a difference of squares? One of them can, but one of them cannot. Yeah, can, right? So this is a difference of squares here, but this is not a difference of squares. 5x squared minus 4 can't get factored any further. What does this difference of squares factor into? X times x is x squared, and 1 times 1 is 1. So 1 gets a plus, 1 gets a minus. So I could have had 4 different factors, but I only had 3. This could have gotten split up a little bit further if it had been like x squared minus 4. All right, so quadratic form and grouping. So let's go to the next page. Let me see. Could you, for now, kind of cross off number 1 and 2, but the rest are grouping or quadratic form. So let's see, for the interest of time, maybe you want to try like 3 and 4, and then skip for now 5 and 6, because those are the exact same strategy as 3 and 4. Skip down and try 7 and 8. So on the practice, use the new strategy that we just learned. Use a partner. I can come around. Try 2 that are the ones we just did, and 2 that are the grouping or the box method, the cubic. Let's just see, if you tried the couple at the top, this would be a squared plus 5 and a squared plus 1 that couldn't go any further. And then this one was what? x squared. We want to use 5 and 3, right? Minus 5 and minus 3 to get to 15. And then the other two, if I do it by grouping here, 8r squared times r minus 8, and then 1 times r minus 8. So r minus 8, 8r squared plus 1. Does that sound like what you got? Did anyone try number 7 and get that as their answer? And then the other one, which could you factor out? A 4v squared 7v plus 4. Does that sound right? And a negative 3 times 7v plus 4, right? So 7v plus 4 and 4v squared minus 3. Don't feel like you have to write all those down. I mean, I'm not grading them. We just did some practice. So whichever